Let's go ahead and take a look at lesson 7.3, which is called More Multiplication Properties of Exponents. We are going to use multiplication properties of exponents. That's our objective today. So when it says raising a power to a power, let's think about this. Let's think about if I have x squared in parentheses and it's being raised to the third power. So let's think about rewriting this in repeated multiplication. What I have in parentheses, we would call the base. 3 would be the exponent. Because 3 is the exponent, that tells me that I want to write that base 3 times being multiplied together. So that takes care of that exponent. Notice then, within each of those parentheses, I want to rewrite those as repeated multiplication. So if I have an x squared in each parenthesis, that means there's 2 x's each time I have a parenthesis. I'm going to drop the parenthesis, but notice that x times x, that makes up this first x squared. Then I have x times x, that is making up the second parenthesis. And then finally I'll have x times x again, which will make up that third parenthesis. Okay, so I've written everything out using repeated multiplication. Now I want us to put it all back together. If I was to take this whole entire repeated multiplication and write it in exponential form, meaning we want one base and we want an exponent with that base. Well, it all has a base of x. If you count up how many x's you have, we have 6 of them. So x to the 6th power would be my answer. So now my question is, how did I go from the numbers 2 and 3, which were my exponents in this original problem? Here I highlighted them in purple. So I started with the 2 and 3. How did I take those numbers and turn it into a 6? Well, we multiplied. 2 times 3 got you 6. That leads us to our formal definition. To find a power of a power, we are going to keep the base. Notice that in the example above, everything was a base of x, and I kept it a base of x. So we keep the base, and we are going to multiply the exponents. Like I said in the problem above, we had 2 and 3. We ended up multiplying them together, and that got us then the 6. So then here, if I have x to the power of m, and that is raised to the power of n. So a power to a power, 2 exponents. That means we keep that x, which is my base, and I multiply the m and the n because those were the exponents. Let's do some practice. In the first problem, we have 4 to the 7th being raised to the 3rd. So we want to identify what the base is because we're going to keep that the same. Notice that in this problem, my base is the number 4. So that means I keep the 4 exactly how it is. It is the exponents that I want to then multiply together. So 7 times 3 is going to give me 21. 4 to the 21st power, because that 21 for an exponent is a positive number, we are done. This is it. 4 to the 21st power is my answer. Taking a look at the next problem, I see a couple of different things here. Notice that -3 is in parentheses. That is your base. Do not lose the parentheses. So I want to keep that base exactly how it is. So I want to write my -3 in parentheses. Once again, I want to focus on those exponents. We have an exponent of 6 and an exponent of 7. Power to a power, I am multiplying these. So multiplying those two together, we keep the base. 6 times 7 is 42. Because 42 is a positive number, we are done. We only don't want negative exponents. So yes, the base is negative, but that is okay. It's just the exponent that I do not want negative. Moving on to the next example, we have y to the third raised to the negative fourth power. So hopefully we're all okay with identifying the base. The base would be y. So I want to keep that exactly how it is. But because we have a power to a power, we are going to multiply those two exponents. So 3 times negative 4 is negative 12. Notice that this time my exponent is negative, and I do not want a negative exponent for my final answer. So I have to think about putting it as a fraction, so make it over 1. I am going to then have to move that whole entire term from the top down to the bottom to change the exponent from a negative now to a positive. So 1 over y to the 12th power is my answer. In this last example here, notice that I have two separate problems within one. So I'm going to first focus on this part on the left. We have x to the third power raised to the negative second. So notice that we have a power to a power. I am going to keep that x exactly how it is because that was the base. But remember, I then want to multiply the exponents together. So 3 times negative 1 will turn that into negative 3. Now I want to move over to the second half of this problem on the right. Notice how we have a base of x, so I keep that base how it is. Because we have a power to a power, I am going to multiply those two numbers together. So I keep my base of x. Negative 6 times 2 is negative 12. Notice that after I took care of those powers to a power, I am going to see that, hey, I'm not done, because notice that I have not only one x, but I have two x's. When that is the case, we want to continue combining them into a single x. So I only want to write that x one time. If you remember, this is from a previous lesson. This is technically being multiplied together. So I'm keeping that base, and remember, that means I want to add my exponents together. So negative 3 plus negative 12. So keeping my base of x, notice that negative 3 plus negative 12 is negative 15. I am still not done. Now this takes me back to that third example. I don't want negative exponents. So I have to think of it as a fraction by putting it over 1. And then the whole entire term on the top moves down to the bottom. I have a fraction, so we'll have the 1 on the top. By moving the x down to the bottom, it changes the exponent to a positive. And so now my answer is complete. So 1 over x to the 15th power. If you turn next page, let's talk about raising a product to a power. So let's think about this. Let's think about this example. If we have x, y squared raised to the second power. So this time I have two different letters or two different terms inside the parentheses, and it's being raised to something outside of the parentheses. So let's start with the fact that this exponent here on the outside, let's do our repeated multiplication. I need to write what I have in parentheses twice. So there's once, there is twice. Once I have written that out, now I want to continue doing my repeated multiplication with any exponent that I see inside. So in the first parenthesis, so this parenthesis right here, I'm going to rewrite it where it still has only one x, but y squared means we have y times y. Moving over then to the second parenthesis, I'm going to write that out using repeated multiplication. So 1x and then y times y. I'm going to start rewriting this into exponential form. Because I have two different letters, let's start with the x. I'm going to write the x, and now I have to figure out the exponent to go with it. Well, notice that there is 2 x's, so I am going to raise that to the second power. Moving on, we have the letter y. Notice that we have, let's get a different highlighter here. We have 1, 2, 3, 4 y's. So that means that we are going to then have y to the 4th power. How did we go from the very beginning of xy squared, all raised to the second power, to x squared, y to the 4th? Well, if you notice that in the original problem, because there was only one x, it technically had an exponent of a 1. So let's think about those exponents. What do I do with the number 1 and the number 2 to make it equal to? Well, I multiply them together. So that was these numbers. So this 1 and then this 2, multiplied them. We got this over here. Okay. Then moving over then to the facts that we have this 2 getting multiplied, that 2 to begin with, and then we have a final answer of 4. So we have a 2 and we want to turn it into a 4. We have this 2 from our original problem. 2 times 2 gets us 4. So essentially, just like the last problem, we are talking about multiplying exponents. Okay, so to find a power of a product, we are going to find the power of each term. And we are going to multiply. Okay, so what I mean by that is, say we have x to the power of m, y to the power of n, and that whole thing is being raised to the power of p. I'm going to keep my base of x. M has its exponent, but it gets multiplied by that outside exponent of a p. I keep the base of y. Its exponent was n. I am multiplying it by the outside exponent of p. So essentially, I am distributing the outside exponent to every exponent inside. Base stays the same. So let's use that information to do a few practice problems. The first problem, we have 5x squared y, all in parentheses, being raised to the 3rd power. So the first thing that I'm going to do is I'm going to find the exponent for everything inside parentheses. Because 5 is the base and I don't see an exponent, I'm going to think of it as the fact that it really has an exponent of a 1. X is raised to the 2nd power. Because y doesn't have an exponent, I once again can think of that as an exponent of a 1. So that means I am going to keep that base of 5. Its exponent was 1. I am going to take the outside exponent, which is 3, and multiply. Then I keep that x. Its exponent was a 2. The 3 is going to get multiplied to it. I keep the base of y. Its exponent was 1. The 3 from the outside gets multiplied to the inside. So notice that keeping the base, 1 times 3 is 3. Keeping the base of x, 2 times 3 is 6. Keeping the base of y, 1 times 3 is 3. Every base is different, so there's no need for us to combine terms any further. Every exponent is positive. That indicates that we are done. Looking at the next example, we have 2x to the negative third power. That is in parentheses, raised to the negative first. So I'm going to start by looking for each exponent inside the parentheses. So the 2, even though we don't see an exponent, really has an exponent of a 1. X has that exponent of negative 3. So I'm going to keep the base of 2. Its exponent is 1. The outside exponent gets multiplied to the inside exponent. So I'm multiplying negative 1 to the positive 1. I'm going to keep the x. Its exponent was negative 3. The outside exponent gets multiplied to the inside exponent. So negative 3 times negative 1. When I multiply those exponents, 1 times negative 1 would be negative 1. Keeping the x, negative 3 times negative 3. Negative 3 times negative 1. A negative times a negative would make that a positive. I am not finished with this problem. While the 2 and the x are different bases, I notice that the 2 has a negative exponent, and I don't want that. So I have to think about it in terms of a fraction, and I only move terms that have negative exponents. So the base of 2, which has the negative exponent, will move down. But the x is going to stay where it is because its exponent is already positive. Now, by moving that exponent down to the bottom, changing it to a positive, it's okay if you write positive 1, or because it is just a single base, you don't technically have to write that exponent of 1. So x to the third power all over 2 is my final answer. All right, sometimes we will have problems where we have to figure out what the missing exponent is in the problem. Notice that we are starting, I'm going to call what's in the box x, and we're going to figure out what that x is. I like the fact that I noticed that there is a 3 for each of the bases. So there's a base of 3 on both sides. That's important. I want those bases to be the same in order to continue this process. When I notice that those bases are the same, I actually get to ignore them, and I want to focus on just the exponents. Because this is a power to a power, what we were just practicing is that I want to multiply them together. So these two exponents are getting multiplied. So 6 times x is 6x. That is then going to equal the exponent on the other side, which is negative 24. Now I just want to solve for x, and then I found my answer. So because we are multiplying x by 6, to undo multiplication, we will divide. That will get you the x by itself, which once again, x is representing the box that we are trying to figure out what number should go inside. Negative 24 divided by 6 would be negative 4. So negative 4 is that number that should really be going in the box to make that a true statement. Taking a look at the next example, we have d to a power, which I'm going to call that x. That is raised to the negative 5th, and that equals d to the 15th power. So notice that base of d on the left and a base of d on the right. So because the base is the exact same thing on both sides of the equation, we get to ignore that base. I want to focus on solving for the exponent. Because we are dealing with a power to a power, we are going to multiply those x's or the x and the negative 5 together. So when I do that, x times negative 5 would give me negative 5x. That is going to equal then the exponent on the other side, which is 15. Now I want to start solving for x because that's what should go in the box. So to get rid of a negative 5, I want to undo multiplication, which means we are dividing. That then gets rid of the negative 5 connected to the x. 15 divided by negative 5 would be negative 3. So that is the number that is supposed to be in the box. And that is it.